It begins not with a rocket, not even with a blueprint, but with a question, one so bold it echoes through the silence of space itself. What if the moon could become our second home, not a distant dream or a backdrop for flags and footprints, but a living, breathing extension of Earth's reach? A place where humans walk, work, build, and thrive, not for days or weeks, but for months, years, even generations. This isn't science fiction anymore. It's SpaceX's roadmap. And the journey to a permanent lunar base isn't just on paper, it's in motion. When you look up at the moon, what do you see? A pale, cratered face glowing softly in the night sky? Or do you see the next frontier, one that could redefine the human experience forever? For SpaceX, it's the latter. Elon Musk's ambitions have long been associated with Mars, but the moon is the vital stepping stone in that grand vision. Establishing a base there isn't just about reaching another world, it's about proving that humanity can endure, adapt, and expand beyond Earth in a real and permanent way. And at the heart of this vision is Starship. Starship is unlike anything that's ever flown before. A towering stainless steel monolith, fully reusable, capable of lifting over 100 metric tons into orbit and landing again with pinpoint accuracy. More than a rocket, it's a system, a bridge between Earth and the cosmos. And for the moon, it's the workhorse that makes every other step possible. Its immense payload capacity means it can deliver everything a lunar base would need: pressurized habitat modules, scientific instruments, power systems, life support gear, robotic rovers, and eventually, the people who will call the moon home. The first phase of this mission is infrastructure, laying the foundation, both figuratively and literally. Starship's cargo bays can carry modular base components, designed to lock together like oversized Lego bricks, forming the early shell of a lunar habitat. These modules must be rugged, airtight, and shielded from the moon's harsh environment, extreme temperature swings, high radiation, and relentless micrometeoroid impacts. Starship makes it possible to send these components in bulk, accelerating the pace of construction while minimizing cost. But building on the moon isn't like assembling a prefab house on Earth. Every bolt, every beam, must survive in a place with no atmosphere, where days last 2 Earth weeks and temperatures can swing from boiling hot to cryogenic cold. So SpaceX isn't just planning to send materials from Earth, they're exploring ways to build with the moon. Enter 3D printing with lunar regolith. By using the moon's dusty surface as a raw material, robots could print protective structures, storage domes, or radiation shelters right where they're needed. This drastically cuts down on mass that must be launched from Earth, making the operation vastly more sustainable. To find the best location for this base, robotic scouts will be sent ahead. These autonomous explorers will map terrain, study the soil, and search for vital resources like water ice, trapped in the permanent shadows of craters near the moon's south pole. That ice isn't just a potential water source for astronauts, it's hydrogen and oxygen, the building blocks of rocket fuel and breathable air. Unlocking those resources could turn the lunar base from a temporary camp into a long-term, self-sustaining outpost. Energy is the next critical challenge. Solar power is abundant on the moon, but it's inconsistent. The 2-week lunar night presents a serious hurdle. That's why SpaceX and its partners are exploring a range of energy solutions, from compact nuclear reactors to advanced energy storage systems capable of powering the base through extended darkness. Energy isn't just for keeping the lights on, it powers life support, heating, communications, and the machines that will build and maintain the base. Every human mission to the moon will be a test of endurance. Astronauts will need advanced life support systems capable of recycling air, water, and waste. They'll need food production technologies, radiation shielding, and medical care, all designed to function far from Earth. These systems must be efficient, fail-safe, and modular, able to expand as more crew members arrive. Starship's frequent flights could serve as a supply chain, delivering essentials, but the goal is independence. That means in situ resource utilization, using what the moon provides to keep humans alive. Over time, the base will grow. What begins as a cluster of modules may become a network of habitats, labs, workshops, and storage facilities. Tunnels could be carved into the regolith for added protection. Inflatable habitats might provide large-volume living space. Surface vehicles will connect distant points, transporting crew and cargo between landing pads, research stations, and exploration sites. Each addition brings the base closer to a functioning settlement, not just a destination, but a place where humanity lives and works on another world. But this isn't just about survival. It's about science, collaboration, and legacy. The Moon offers a unique platform for astronomical research, free from Earth's atmosphere and radio noise. Telescopes placed on its surface could peer deeper into the universe than ever before. Geological studies could unlock secrets about the Moon's origins, and by extension, Earth's early history. And international partners, from NASA and ESA to private companies and academic institutions, could all share in the effort, turning the Moon into a hub of scientific discovery and human cooperation. The base will also serve a higher purpose, preparing us for Mars. The challenges of building, living, and working on the Moon mirror many of the obstacles we'll face on the Red Planet, only closer to home. From life support and habitat construction to dealing with isolation and communication delays, the Moon is a perfect proving ground. Technologies developed here will pave the way for Mars missions, helping engineers fine-tune systems in a real-world environment before committing to the much longer and riskier journey. And Starship will be the constant thread. Its reusability means not only cost savings, but logistical flexibility. Missions can be launched, paused, and relaunched as needed. Supplies can arrive regularly. Crew rotations become feasible. And as Starship evolves, newer variants may carry even more cargo, greater capability, and longer-range systems that make the Moon not just reachable, but routine. Still, the risks are enormous. Launch failures, landing mishaps, life support malfunctions, all are real possibilities. Every module must be tested, every contingency planned. And beyond technical hurdles lies the psychological frontier. Life on the Moon will be isolating, confined, and mentally demanding. Astronauts will face darkness for weeks, silence unbroken by wind or wildlife, and the ever-present awareness that outside the walls lies instant death. But they will also experience something no one on Earth can fully understand, the birth of a new chapter in human existence. This lunar base isn't just a SpaceX project. It's a planetary milestone. It will redefine what it means to be human in space. It will inspire generations. And it will remind us that the Moon is not just a symbol of dreams, it's a destination. The journey begins now. Starship is flying. The technology is coming together. The plans are evolving from sketches into hardware. This isn't a distant ambition, it's a tangible, measurable objective. And if it succeeds, we won't just be going to the Moon. We'll be staying. Absolutely. Here's part 2, 1,500 words, of the rewritten script for SpaceX's Moon Base, a step-by-step guide, continuing directly from part 1. It maintains the same cinematic tone, immersive detail, voiceover optimized pacing, and follows your standard script requirements. Exactly 1,500 words, no headings, summaries, or skipped elements. But to stay means more than building walls and sealing in air. It means creating a system where people can live, work, solve problems, and innovate in real time. SpaceX's lunar base isn't just about surviving on the Moon, it's about thriving. That goal demands more than engineering. It requires strategy, adaptability, and above all, vision. As the base expands, so too does its purpose. What begins as an outpost becomes a hub. What starts as a mission evolves into a settlement. Imagine the future astronauts stepping down onto the dusty regolith, not as visitors, but as residents. Their tasks won't just involve exploration, they'll repair solar panels, cultivate food in hydroponic greenhouses, calibrate scientific instruments, and coordinate with Earth in real time. But communication isn't instantaneous. Even the moon, at just over a second and a half delay each way, introduces friction in decision-making. That's why autonomy and on-site leadership will matter. Crews must be empowered to make complex decisions without waiting for permission from Earth. And in that environment, every action has weight. Water must be conserved. Air must be recycled. Waste isn't waste, it's a resource to be managed. Every screw, every sensor, every ounce of battery power counts. Precision becomes culture. Efficiency becomes survival. And this pressure breeds innovation. Already, engineers are designing closed-loop systems that recycle nearly everything. Water filtration systems so advanced they can extract moisture from exhaled breath. Air processors that scrub carbon dioxide and rainfuse oxygen. Waste-to-energy converters that use bio-waste to power lights and heat. Energy, of course, remains one of the greatest hurdles. A lunar base can't rely solely on solar panels when the moon plunges into darkness for 14 Earth days at a time. Some solutions are already under active development, modular fission reactors that can provide constant, stable power regardless of sunlight. Others are more experimental, like lunar lava tube habitats powered by buried geothermal heat, or cryogenic storage batteries capable of banking solar energy during the long lunar day for use during the night. And then there's safety. On Earth, we have an atmosphere, a magnetic field, and gravity to protect us. On the moon, none of those safeguards exist. Cosmic rays and solar radiation bombard the surface constantly. That's why shielding is critical. Some habitat modules may be buried under meters of regolith to shield from radiation. Others might use water jackets or deploy inflatable shields filled with hydrogen-rich polymers. Even the shape of the habitat matters. Curved walls better deflect radiation and resist pressure differentials. The danger isn't just from above. The moon's surface is treacherous, fine dust that sticks to everything and grinds down equipment, jagged rocks, and craters that can swallow a rover whole. Mobility systems, rovers, suits, even walking mechanisms, have to be designed for extreme conditions. NASA's Artemis program, working in tandem with SpaceX, is already testing next-generation lunar suits, lightweight, flexible, and durable under vacuum. These suits will become the daily uniform of lunar explorers, balancing freedom of motion with life-saving protection. Transport, too, evolves. While Starship may be the vehicle that brings humans to and from the moon, mobility on the surface requires a new class of vehicle entirely. Pressurized rovers that allow for long-range exploration without needing to wear a suit inside. Cargo haulers that move regolith, tools, and structural components across kilometers. Flying drones, yes, even in 1/6 gravity, engineered for scouting or inspecting remote installations. This interconnected web of movement, construction, energy, and survival forms the backbone of the lunar base. But the real transformation comes not from machines, but from the people who live there. The first settlers will be scientists, engineers, and astronauts. But as infrastructure solidifies, new roles emerge. Doctors. Technicians. Data analysts. Eventually even artists, educators, and communicators. The base becomes a microcosm of Earth, not just a research station, but a human community. That community will face unique psychological challenges. Living on the moon means confinement. No fresh air. No weather. No casual stroll. Days and nights blurred into operational cycles. Earth reduced to a glowing marble in the sky. To keep minds healthy, base design includes more than just utility. Artificial windows that simulate Earth-like daylight, communal gathering areas, digital interfaces for entertainment and mental health support. Even the layout of modules can affect mood. Open designs reduce claustrophobia, varied textures break monotony, soft lighting reduces eye strain. Mental resilience will become as valuable as technical skill. And community support systems, training in conflict resolution, routine mental health checks, team-building activities, will be as essential as oxygen. Eventually, the Moon Base begins to change the rhythm of Earth's relationship with space. It becomes a staging point for further missions, not just to explore, but to launch. Imagine Starship refueling on the Moon before heading to Mars. Imagine supply depots, cryogenic fuel plants, and orbital launch towers all rising from the lunar surface. The Moon becomes a celestial pit stop, shortening the path to the outer solar system and reducing the cost of deep space exploration by orders of magnitude. Because escaping Earth's gravity is the hardest part of any mission. But from the Moon, with only 1/6 gravity, the energy needed to launch is dramatically lower. A base on the Moon isn't just a home, it's a springboard. A literal platform to the planets beyond. And with that comes economic opportunity. What was once a realm for governments becomes a new market frontier. Private industry joins the effort. Mining operations study the feasibility of extracting rare lunar minerals. Oxygen production plants built from regolith electrolysis. Data relay stations. Construction firms specializing in off-world architecture. An entirely new sector of commerce emerges, space infrastructure development, where contracts are written in kilograms delivered and what's generated rather than dollars alone. International partnerships also deepen. The Moon Base isn't built in isolation. SpaceX is working closely with NASA, and agencies from Europe, Japan, Canada, and others are contributing everything from robotics to scientific payloads. These joint missions build trust, create shared standards, and establish the framework for long-term cooperation in space. In the near future, it's entirely plausible that a lunar base might include modules from 5 or more nations, each bringing their strengths to a shared frontier. That unity could have powerful echoes back on Earth. Just as the International Space Station proved that former adversaries could work side by side, the Moon may serve as neutral ground for shared purpose, science, survival, and the expansion of human presence beyond any single flag. And through it all, the public watches. Every launch. Every touchdown. Every image from the Moon. Children will grow up dreaming not of becoming astronauts, but lunar architects, off-world engineers, or space doctors. A new generation raised with the Moon as part of their mental map. And when the first school is built on the Moon, or the first child is born there, the idea of being a multiplanetary species will no longer be a dream. It will be a fact. But the journey isn't without friction. There will be setbacks. Starships might crash. Modules might fail. Lives will be risked. Mistakes will be made. And critics will question whether the effort is worth the cost. But those challenges have always followed exploration. From sailing ships crossing oceans to planes shrinking the globe, every great leap has begun with danger and uncertainty. Because the Moon isn't just a target. It's a mirror. It reflects what we dare to reach for, and how far we're willing to go to get there. And now, with SpaceX building the vehicle, the vision, and the momentum, humanity stands closer than ever to turning that reflection into reality. A fully operational Moon base will change how we view Earth. It will teach us how to live with limited resources. How to innovate without fallback options. How to sustain life in the most inhospitable environments. And it will prepare us for the harder challenge ahead, Mars. Because if we can learn to live on the Moon, even in its silence and dust and darkness, we'll be ready to step farther. To plant roots not just in orbit, but in the soil of other worlds. To push past the boundaries that once held us back. SpaceX is already testing the systems. Launches are underway. Contracts are signed. Designs are refined. The Moon base isn't theory. It's trajectory. And it's accelerating. In just a few short years, we may see the first permanent structures rise from the lunar surface, metal, glass, and regolith fused into the shape of a future that belongs to all of us. So the next time you look up and see the Moon glowing in the night sky, remember, someone, someday soon, will be looking back. Not from a rocket or a capsule, but from their window. On the Moon. In a base. Built by us. For all of us.